Hello, welcome to Core Connections Algebra, homework questions 57 through 61 in Chapter 1. Question 57. If f of x equals x squared, then f of 4 equals 4 squared, which is equal to 16. So if we want to find f of 1, then what we want to do, wherever there's an x, we replace it with 1. So f of 1 is equal to, and then this x gets replaced with 1 squared. So what is 1 times 1? 1 times 1 is 1, so therefore f of 1 is equal to 1. B, f of negative 3. And so here's the end result right there. That's what we're looking for. So it gives us the input, we're looking for the output. F of negative 3, wherever there's an x, we plug it in. In this case, x is being squared, so we square the negative also. So negative 3 times negative 3 is 9. So therefore, f of negative 3 is equal to 9. Remember, this number right here represents the input. The 9 represents the output. And the f represents the function that we're talking about. And they can be labeled different things. F is a common one, though. And then C, it says f of t. So we still apply the same idea that wherever there's an x, we replace it with t. So if x is being squared, now it becomes t squared. And in this case, we can't simplify, so the output is t squared. Question 58. Evaluate each expression. You can use a calculator if you want to on this, but we're going to just work through them without one. The cube root of 27, so the question we are trying to answer is what times itself 3 times gives you 27? And that would be 3. 3 times 3 times 3 is 27. On the square root of 144, that's a 2 there, so now we're asking a similar question, but now we just want to know what number times itself will give you 144. So what number times itself gives you 144? And that would be 12. For C, we could use what we learned in terms about inverse square roots and squares being inverses of each other. They undo each other. So since this is a square root and the 3 is being squared, they cancel each other out and it gives you 3. To expand this a little bit, this is the same thing as the square root of 9. Alright, so then the question is, what times what gives you 9? And then that would be x equals 3. So either way, you could address this problem. On the next one, we're going to go ahead and use the inverse idea of how they undo. So the fourth root and the fourth power undo each other. So therefore, the fourth root of 2 to the fourth is just equal to 2. So in question 59, it says graph and fully describe the function. Really strongly suggest at this point that I went ahead and created a table for you, but you can find that using the graphing calculator or Desmos. Really our focus on this one is to fully describe the function. So if we graph this, negative 8 would be at negative 4, so we'd have a point here, negative 1, negative 3, 0, negative 2, and then we have 1, negative 1. Whoops, that last one didn't go down far enough. 0, negative 2. There we go. 1, negative 1. 8, 0. And then I had 27 and 1, but that's way off the graph. So it'll look something like this. And it should continue to go up and down. I kind of missed that last point. But that's what the cube root is going to look like. So now the bigger question is, let's fully describe this. So think about those questions that we had asked. In terms of what does the shape look like, what are the intercepts, is there symmetry, how does the graph grow, does it increase, does it decrease? So think of those questions and write down as much as you can. Are there any special points? And then I'll write it down and see if ours compare. So now compare your description of the graph to my description. And obviously it doesn't have to be word for word, but you do need to have all of these things in your description in terms of the shape, in terms of how it's growing. You could say in this case the graph is increasing, or we can say as x increases, y increases. You need to include any of your intercepts where the graph crosses the x and y axis. Is there symmetry, and are there any max or minimum values? So once again, make sure all of those different things are included in your description. Question 60. A line passes through the points -3, -2. So remember, -3, -2, your x is -3. So we'll go over here, -3, and then down -2. So that's where that point is located. Label it A. B is at 2, 1. So 2, and then 1 up. Remember your ordered pair. X is first and then Y. So this represents X, this represents Y. So we have a line that passes through the points. Does it also pass through the point 5, 3? So if we graph this line, I'm going to try to do an accurate job here since I don't have a straight edge that I can use. So what I'm going to do is I'm going to count 1, 2, 3, and then 1, 2, 3, 4, 5. That way I'm consistent with my counting. So my next point would be 1, 2, 3, 1, 2, 3, 4, 5. So I know I'll have a point here. I can also go down 3 and then 1, 2, 3, 4, 5. And so here would be a little bit more accurate of a line through those 2 points. So the question is, does the point 5, 3 intersect that line also as it passed through? So 1, 2, 3, 4, 5. 1, 2, 3. So does it cross that line, or does it pass through? And it's very close, and if you're not accurate with this, you might think it passes through, but based on the work that I showed, you can see that it just misses passing through that point. Question 61. Find the following absolute values. So remember, absolute value is distance from 0. So the absolute value of 0.75 is just 0.75. The absolute value of -99 is +99. On part C, we have to do a little bit of work here. We do multiplication first, then we do our subtraction, and then we take the absolute value. So the answer there would be 2. And pi is an irrational number, but it still works the same way with absolute value. It's still pi units away. So you notice that all the values are positive, and that will always be true with an absolute value. They have to be greater than or equal to 0, because when you take the absolute value of a negative, that distance is going to be a positive.